As the title implies, in this video I'm going to be going over how strong the Jujutsu Kaisen verse is. This is going to be a bit different from my normal scaling content, as instead of focusing on one character, I'm going to be going over just a bunch of feats performed by multiple different characters throughout the entire series in chronological order and calculating them. I got this idea from DC Does Physics here on YouTube and TikTok, who made a video on how strong the One Piece verse is. And I really liked that video, so I decided to make my own version of that. And seeing as Jujutsu Kaisen doesn't really get a lot of love in the scaling community, I decided to make it the focus of this video. So let's get into the scaling. Chapter 0-3 Geto blitzes everyone. In Volume 0, Chapter 3, Geto blitzes Yuta and the others. For blitzing calcs, we can generally use two different time frames, these being 0.273 seconds for the average human's reaction speed and 0.013 seconds for the average human's perception speed. For this, I'll be using perception speed, as Geto was moving so fast that nobody could even see him. Now for the distance he had to move, Yuta is 1.5 meters tall, and in this image he is 65 pixels tall. The panel is 480 pixels tall, and so plugging that into this formula, we get a distance of 9.2 meters. The speed formula is distance divided by time, so 9.2 divided by 0.013 gives us a speed of roughly 700 meters per second, or about Mach 2.1, which is a pretty good speed feat for a very casual Geto. Chapter 7. The finger bearer pulverizes a wall. In Chapter 7, the finger bearer destroys a large wall. For the size of the wall, we first need to find the height of the finger bearer. Now, it doesn't have an officially listed height, so I had to find it myself. Itadori is 173 centimeters tall, and by using this image, we find that his head is about 23.1 centimeters tall. Now that we know that, we can find how much taller the finger bearer is. Using this image, we find that the finger bearer is about 20 centimeters taller than Itadori, or 193 centimeters tall. Hopping back to the first image, 1 pixel is equal to about 11.3 centimeters, so the diameter of the hole would be equal to 14.12 meters. The depth is equal to 33.9 centimeters, and seeing as it is a cylinder, that gives us a volume of 61.5 million cubic centimeters. And so about half of this circle that we drew was actually destroyed. The true volume is 30.7 million cubic centimeters. Judging by the debris, I'll assume that this is 50% fragmentation and 50% pulverization. The fragmentation of reinforced concrete is 10 joules per cubic centimeters, and pulverization of reinforced concrete is 610 joules per cubic centimeter. This means that the energy needed to destroy this wall is about 9.5 times 10 to the power 9 joules, or large building level. Chapter 13. Jogo melts the road. In Chapter 13, Jogo melts part of the road in an attempt to kill Gojo. The road here would be made from cement, and the energy needed to melt cement is about 12,000 joules per cubic centimeter. To find the volume of the melted road, we can use the road divider to measure the size of the fire blast. Road dividers are usually around 15 centimeters wide, so by using that, we find that the width of the fire blast is around 990 centimeters, and the height is 918 centimeters. This means that it has a volume of 235 million cubic centimeters. Divide that by 2, and we get 117 million cubic centimeters for the part of the road that was actually melted. 117 million times 12,000 equals 1.4 times 10 to the power of 12 joules, or multi-city block level. Chapter 18. Dagon's domain expansion. In Chapter 18, we first get to see Dagon's domain expansion, which is a small island surrounded by an ocean. To find the energy needed to create this domain, we first have to know how much it weighs. To do that, we have to make a few assumptions. The first one being, how far is it to the end of the domain? 2. How deep does the ocean go? And 3. How big is the island? For the distance to the edge of the domain, I'll assume that it's about the same distance as the horizon would be for a normal person standing on the Earth, or around 4.8 kilometers. For the depths, I'll use one lowball and one highball estimate, the lowball being the ocean depth of the eastern China Sea. This is the sea between Japan and China, and it's on average 350 meters deep. And for a highball, I'll use the average ocean depth all around the world, which is 3 kilometers. For the island, I'll assume that it's roughly circular and has a radius of about 500 meters. Why? Well, it's shown as being pretty small, and so being 1 kilometer wide, I think is a pretty fair estimate in my opinion. And putting this all together, the domain has a radius of 5,300 meters, and it's between 350 meters and 3,000 meters deep. This gives us two volumes, these being 30 billion cubic meters and 264 billion cubic meters. The weight of water is 1,000 kilos per cubic meter. This gives us a weight of either 3 times 10 to the power of 13 kilos or 2.6 times 10 to the power of 14 kilos, which gives us town level to large town levels of energy respectively. Now, yes, I did include the island here as being water, but that doesn't really change anything, so I didn't bother putting in the value for soil and sand and stuff like that. Chapter 42, Maki catches a bullet at point-blank range. In Maki's fight against her sister, she manages to catch a bullet right before it hits her. Mai's gun resembles a standard revolver, which has a muzzle velocity in the 300 meters per second ranges. However, the argument can be made that she's using a rubber bullet, which would give the bullet a speed of around 60 meters per second. Maki has a listed height of 170 centimeters, so by using this image we find that her eye is around 1.5 centimeters tall. Now we know that, we can find the distance between her and the bullet, which is around 3.2 centimeters. This gives us a time frame of between 0.0005 seconds and 0.0001 seconds. Using the image we used to find the size of Maki's eye, we can find the length of her arm from shoulder to palm, which I got to 57 centimeters. She had to move her arm roughly 90 degrees to catch the bullet, which means that she had to move her arm around 51 centimeters. This gives us a speed of between 1,200 meters per second and 5,100 meters per second, or Mach 3 and Mach 15. I would lean more towards Mach 15 because Mai's technique is that she creates regular bullets, not rubber bullets. And the damage done to Maki would not have been that severe if it were to be a rubber bullet. Chapter 45, Hanami Blitzes Megumi. In Chapter 45, we see Hanami blitz Megumi. Hanami has a listed height of 220 centimeters, and in this image he is 62 pixels tall, which means 1 pixel is equal to 3.5 centimeters. The distance between Hanami and Megumi is 378 pixels or 13.2 meters. Time frame here would be 1.013 seconds, as they couldn't see Hanami move and they were off guard. So this gives us a speed of 1015 meters per second or Mach 3. Moving on to the Shibuya incident arc with chapter 115, Sukuna slams Gojo through multiple stories. In chapter 15, Sukuna slams Jogo through multiple stories, pulverizing each floor. Itadori's head, which we established earlier, is 23.1 centimeters tall, which means that the diameter of the hole Sukuna created is 3.2 meters. Then we can find the depth of the hole, which is 0.5 meters, which gives us a volume of 4 cubic meters. Since he broke through 8 floors, this instead gives us a volume of 32 cubic meters or 32 million cubic centimeters. Pulverization of reinforced concrete, like I said earlier, is 610 joules per cubic centimeter, so that gives us 1.9 times 10 to the power of 10 joules or a large building level. Staying in chapter 115, we have Jogo's maximum meteor. I'll be calculating both the energy needed to create the meteor as well as its kinetic energy. A standard 2-lane road is 52 meters wide, and in this panel the road is 33 pixels wide, which means that 1 pixel is equal to 0.17 meters. The meteor is 315 pixels wide, which means that it has a diameter of 54.4 meters, and this gives us a volume of 84,000 cubic meters. The density of meteors is around 350 kilos per cubic meter, which gives us a weight of 2.9 times 10 to the power of 8 kilos, which is building level. Not that impressive, but let's move on to the kinetic energy. This panel is 887 pixels tall, and the meteor is 247 pixels wide, and its diameter is 54.4 meters. Again, using this formula, we get a distance of 139.5 meters. Using this freeform calculator, we get a kinetic energy of 3.9 times 10 to the power of 11 joules or multi-city block level. Chapter 149, Maki blitzes Ogi. After Mai sacrifices herself to give Maki a massive power buff, she blitzes Ogi from a long distance away. First, we need to find the distance from the doorway to Ogi. We can use Maki to find the width of the stairs, and by extension the width of the doorway. Maki is 170 centimeters tall, which means that 1 pixel is equal to 1.16 centimeters. The stairs are 317 pixels wide, which makes them 3.67 meters wide. Then, using this image, we find that the panel is 488 pixels tall. The doorway is 190 pixels wide, so by using the angle size formula, we get a distance of 11.7 meters. Maki also went past Ogi. By using the same formula, we find that she moved an additional 1.8 meters, which gives us a total distance of 13.5 meters. We're using 0.013 seconds as our time frame, we get a speed of 1038 meters per second, or Mach 3. Chapter 191. Curse Naoya blitzes Kamo. In chapter 191, Naoya's vengeful spirit completely blitzes Kamo and moves an extreme distance before Kamo can even process what's happening. Windows can vary in height, but I'll use this window, which is 1.6 meters tall. The window is 7 pixels tall in this image, so that means that 1 pixel is equal to 0.22 meters. Naoya had to move at least 1041 pixels, or 237.9 meters. The time frame is yet again 0.013 seconds, which gives us a whopping speed of 18,000 meters per second, or Mach 53. Now, you might try and debunk this kind of speed by saying that Naoya was stated to have a top speed of Mach 3, but as you have seen throughout this entire video, there are multiple feats by weaker characters that are Mach 3 or faster. But if you want an in-universe explanation for why Naoya's top speed can be both 53 and Mach 3, you can simply just say that the speed of sound is faster in Jujutsu Kaisen than it is in the real world. Chapter 221, Gojo creates a small earthquake. This is the final and most impressive feat in the series up to this point. In chapter 221, Gojo is released from the prison realm, and when this happens, he creates a small earthquake that is felt by Itadori and the others who are in Saitama Prefecture. We first need to find the magnitude of the earthquake that Itadori felt. The shaking was shown as being pretty intense, and so I'll assume that Itadori and the others felt a magnitude 5 earthquake. But that's just the magnitude at distance. Because Gojo was stuck in the Japanese trench when he caused the earthquake, it means that the earthquake at the epicenter, or where Gojo was, would be much more powerful. The trench is very long, and so we don't know exactly where Gojo is, and so I'll use 3 different locations. Location 1 is 281 kilometers away from Saitama Prefecture, location 2 is 407 kilometers away from Saitama Prefecture, and location 3 is 526 kilometers away from Saitama Prefecture. Using this formula to find the magnitude at the epicenter, we get 3 different magnitudes. From shortest to longest distance, these values are magnitude 7.5, magnitude 8.1, and magnitude 8.6. Then by using this formula, we can find the amount of joules released from each earthquake. This gives us 3 different values. 1.1 times 10 to the power of 16 joules, 8.9 times 10 to the power of 16 joules, and 5 times 10 to the power of 17 joules. This gives us small city level, and baseline mountain levels of energy respectively. With all of these feats, we can estimate the power of most characters in the series. Low to mid tiers, such as the first finger bearer, should be around large building level and supersonic plus. High tiers, such as Itadori, Jogo, and Maki, should be around multi-city block level to possibly large town level, with high hypersonic to high hypersonic plus levels of speed. And top tiers, such as Gojo and Sukuna, should be around city to mountain level with massively hypersonic levels of speed.